Well, it's not working in prod. Indeed, it's not working in prod. Well, it's not my problem. It works just fine on my machine and on the dev server. Well,
I told you all systems are ISOs. And if it's working in dev, it's working in prod.
it's ISO?
Oh yeah, essentially, I mean, pretty much almost.
Almost? What do you mean, almost?
You know, there's maybe a very small gap in minor versions, and for some plugins. Nothing particularly important.
All right. Hello, everybody. Oh, let me turn off your screen sharing. We were practicing testing beforehand. Thanks, everybody. Welcome our weekly live stream here on Docker Build. And today we got a great guest on all the way from AWS, one of our partner solution architects. So Anuj, welcome. Thanks for joining us.
No, thanks, Peter, for having us. It's looking forward, and it's really good to be here.
Yeah, awesome. I'm excited to have you on. I know we've been talking for a couple of weeks, and what we're going to show, and I think we got some really cool stuff to show. But a little bit about Anuj. So been at AWS for over 7 years. He's a container specialist solutions architect at AWS. He manages us. Docker keeps real good care of us and helps us do a really bunch of cool stuff. Before that, has 15 years of experience in the industry with application development, infrastructure development. And when he's not geeking out, nerding out, you can find him hiking on Mount Rainier. That's pretty cool. Yeah. Awesome. Well, normally we chit chat for a little bit and you hear me just ask you random questions, but we got a lot of stuff to show today. I'm super excited. So why don't we just dive right into it, and then we can take it from there.
Absolutely.
Okay.
Let's get started. I think we'll get some time to chat in between for sure. So what we work specifically about an experience that we have heard from many customers and interacting with a lot of customers that, hey, we have applications running on to migrate to cloud, but the experience of making an application run on premise versus the application running on cloud, it's quite different for the developers. Developers use a different tool in on-premise versus developers use a different tool when the applications run in cloud. So what we thought that, hey, let's talk about a really cool enhancement that we did in Docker Compose late last year, which kind of solves this problem to a great extent. That, hey, if you have a containerized application which is running on premise and you want to migrate that to AWS without making any changes in the experience, without making any change in the developer experience, to be very specific, how would you actually go about doing that? So in the session today, what I have is a sample application. A sample 3-tier application includes a presentation layer, which includes an application layer and a database. The presentation layer is currently it's a proxy layer, but in a real scenario, it's replaced with an HTTP server or an Angular app, to be specific. The application layer has the business logic, and we'll see what exactly is that. And that fetches the records to a MySQL server and kind of retrieves the record here. Right. So from an application perspective, two-component application. First one being the proxy layer, that is pretty straightforward. It's just acting as a proxy pass. It has a Docker file, nothing but an Nginx Docker file. The next layer is the backend, and it's just a Flask application. Now, what Flask application accepts the input of the database, the user, and host, and of course the password, using the password file and what that how to use in with Docker secrets, and defaults to some defaults if that is the case. It will insert the record basically if you do the default route of /, retrieves the records whatever are present in the database, and appends few HTML tags and to display in the front end. It has a different route called /add with an ID and a name, and that will connect to the database with the same method that we created, and again display the records which are appended. From a microfile perspective, straightforward, Python 3.8 base image, do the pip install for the requirements file, and run the Flask app. Now, if you had to run this application in your local desktop, or let's say in your own device, you will actually create a Docker Compose file, something like this, which has the proxy layer. You build the proxy layer with the specified folder. So build with a specific context with a specific folder builds the Docker file with the networks of with a dependency on the backend and the network of the front end. Now, the backend being building the backend with a specified folder dependence on the database, and network being front end, and lastly the database layer, MySQL 8.0 with network as backend, and some environment variables that we are injecting. In the local environments, we are using volumes, which mounts to a specific folder, as well as secrets. In the local environment, I have a password file which gets mounted to run secrets folder, and it gets mounted to this folder, which is read by the application using the environment variables. So that's the local setup looks like.
Awesome.
Now, and Peter, feel free to just interrupt me at any point of time if there are any questions.
Yeah. Yeah. I do have one thing to explain a little, because it's so this is great. We got a little more complex compose file, right? And we're using 2 networks, which is great. It's the way to isolate your front end from your back end and have that your service layer shares both those networks. So your backend database lives on a network that's not exposed to the outside world, which is really cool. Yeah,
exactly. Right, and so that is the local implementation, right? And there are like ways how that is done locally. So let's run this application and see what it looks like. So have this application. Let's do, and just for demo purpose, let's see context, what all the context I have, and currently it is just the default context.
Oh, there we go. Okay, cool. Now we couldn't see your terminal for a sec, but we can see it.
Oh,
now. Awesome.
Okay.
Perfect.
Nice. So now let's do Docker Compose up, and that is creating. Starting, I have the build all done. So image data and simply builds it. So now it is running. Let's see how it looks like if I open in the machine localhost. Localhost. That is just an initial load, and let's say if I add my name, that will appear here, and let's just to make it see side by side. Add something else. Here. So that's a forward application from a business logic standpoint. But what it does is it goes through 3 layers of the proxy layer, which would be our front end, the middle tier, which has a business logic to insert the data and retrieve the data, and finally the database layer.
Yeah, it's like you said, I love that. I'm going to totally steal that. It's simple in the business logic, but complex in the setup, right? And it lays
Absolutely.
out that framework for then you can add more complex business logic in it. But yeah,
Yep.
there's a lot going on there for sure.
Yep. Absolutely. And what I like from a local development, sorry, I stopped. Let me start again. What I like from a local development perspective is, I mean, I can run this in a daemon mode, Docker desktop. Yay. to actually go through the entire logs, which I have to go through what exactly is happening inside it, separated by the different kind of images, backend specific logs. So that's pretty neat.
Yeah, cool.
All right. So so what we saw so far, and going back to my whiteboard, is we have this application, and it just now is took this application and deployed it on my local machine using the Docker Compose CLI, which is running on my local machine. Right.
Cool.
Now, next step, right? Now, when the time comes that, hey, let's actually migrate this application further to AWS cloud without modifying the developer experience, how would we go about doing that? So let me switch the console and clear the screens to clear the clutter. So back late in 2020, and it was like preview mode. Before that, there was a pretty neat integration that was released as a GA with Docker Compose. So what it allowed to do is use the same Compose file and essentially the application and deploy to ECS. Now, to give a 30 seconds introduction to Amazon ECS, is it's Amazon container service. That's an orchestrator layer, pretty simple and straightforward. It's meant for the container orchestration purpose, and you can deploy a multi-container application or a single application. It neatly integrates with all the entire AWS ecosystem of IAM roles for better security. It neatly integrates with the load balancers so that you can retrieve the ingress traffic and things like that. So let's see how we will actually go about deploying the same application into Amazon ECS. So first step is, so far we have a Docker context. We have only one Docker context. In order to deploy this application, or in order to run Docker Compose into Amazon ECS, I would actually create another context, and it should be Docker context ECS, and give it a name. I'm going to give it a name of ECS east 1. So what it is doing is creating a context ECS, and this is a pretty name that it. Okay, what thing is create. So all right, now it will provide you 3 options: create an existing profile, use a secret and a credential token, and use environment variables. I'm going to use environment variables here because my credentials to connect to my accounts are stored in environment variables. But like, there are different options. If you have your profile, you can use that, or if you have any IAM user that you want to use that. But I use a token service to retrieve the credentials and use that. Now, so far, we created the context locally, and I would go about inspecting it. I would do Docker context. So it created 2 contexts. We have not switched the context yet. So I'll do Docker context use ECS and ES1, so that using the context. If I inspect, will show some specifics of, hey, that's just in case you create it and forget about it.
Yeah.
That's one way to retrieve the details on what exactly is this context doing. Now, so far, we have not gone about deploying in AWS environments. Now is we realize that, hey, we have the database image which we are going to pull, but locally actually build that image. But in a production like scenario, you would be having like a CI/CD system which will build the image and put it up in a repository. So that is one step which I've done already. However, how would you go about overriding and this context will be deploying to cloud, right?
Right.
The answer to that is we'll use Docker file overlays. And let me actually the deployment, and then we can talk about the specifics of the overlays here.
Yes.
Right.
Good.
So Docker compose -f Docker YAML. I have 3 overlays, and I created 3 overlays, 3 compose files just for the demo purpose. But ideally, in my opinion, one per environment suffices the purpose. But I wanted to show what are the different details and different overrides that we are doing. So yeah, we'll do Docker compose.prod.yaml, then -f compose prod prod scaling.yaml. So these 3 are the ones, and we will do Docker. We did Docker compose up. So now this is actually deploying, and whatever variables, whatever the specifics which are getting overwritten and which are not supported in this context will silently fail as a warning. Need to worry about. Now let's see what exactly we did, right? And what exactly is happening. So far we deployed it on locally on the machine, and now we are taking this application and deploying it further to AWS cloud using the same Docker compose CLI. If I have to do this a little bit and talk about what exactly is happening is the first step what Docker compose CLI was generated the CloudFormation templates, or basically the infrastructure as the code. It is all generated by Docker compose Docker compose command, right? Now if I have to see what it generated, let's run this command in a separate tab so that I can see what exact what a CloudFormation template file which is getting created. So here, Docker compose if Docker compose YAML -f.
Can you bump the zoom in a little bit when you get a chance, Anush? Do that so we can. There we go. Perfect.
And then -f Docker compose prod .yaml. So previously we did Docker compose up, and that is deploying in a separate screen, but I wanted to show what Docker compose actually did behind the scene, which is the very first step is generate a CloudFormation template, infrastructure as the code. And for that, we can use Docker compose convert. And I'm going to output the details to a specific YAML file here. Right? Let's see what exactly happened. Now, if I open this in this editor, you'll see that there are around roughly around 800 lines of code which created. We passed an input of around 63 plus few other overrides, but in the end it generated around 765 lines of code, 765 lines of CloudFormation templates. Now we'll see what are the specifics inside this CloudFormation template but that's really awesome. I saved a tons of time, and not to add, when Docker Compose generates the CloudFormation templates, it generates in an opinionated manner. Now, this opinionated manner conforms to the well-architected principle. It generates security as the least privilege. It generates the security groups which are restricted to a specific purpose. It generates IAM role security principle conforming to the security well-architected principle. So it has an opinion, and it fits to the well-architected philosophy of AWS, and it generated deep code. So there is our first benefit, right? We save tons of time in actually authoring CloudFormation templates right away. Now, what is happening? Once this CloudFormation template is actually generated, the next step is to deploy to the context that we already created, right? So if we see to our AWS console, you will see that there is which is getting created, which has the template which we just saw, right? As a developer, I did not interact with AWS CLIs. I did not interact with CloudFormation template. I just used Docker Compose file, which generated in a specific opinionated manner, right? Now, what exactly it generated, right? Because we know that, hey, when we are running something slow, we created some resources like volume. We created resources like network. We created resources like secrets. How are they getting to cloud? Is there a data that is happening somehow somewhere? That's not. So let's go through the details of it, right? So first and foremost, if I see my compose file as an example, let me expand this a little bit. So the compose up command actually use 3 different files. One is compose.yaml, another one is prod.yaml, and third one is prod-scaling.yaml. And I'll talk a little bit of what are the specifics around this. But the reason I split it into different files is purely purpose. Ideally, if you have established this is how your POA architecture is going to look like, you would actually simply put all the specifics into one file and be done with it, right? So we use this prod compose prod.yaml compose file, and we use a specific image which our CI/CD system has already pushed into a specific ECR repository, right? Now, if you have a repository we are authenticating against, right? Let's say in this example, I'm using MySQL, this specific image, and I'm authenticating against Docker Hub. A specific pull credentials, which are my specific Docker ID's pull credentials. I did not pass them anyway in a clear text format, right? What I did was created the secret in AWS Secrets Manager, right? So if I had to go there and go to AWS and go to Secrets Manager, see that there is a secret which is pull creds, and that has my Hub login credentials. So firstly, we reduce this blast surface there and there itself, right? That we are not passing anything in the clear text. We are storing these secrets securely using Secrets Manager, and is simply referring a resource identifier, which is this resource identifier in my file, and using it, right? Now, next question that comes to my mind, as in how would I actually go about creating it, right? Am I not creating a different, am I not interacting with AWS CLI, right? Actually, no, we are not interacting with AWS CLI. How would you actually go about creating a specific secret? It's the same, right? Let's say in your local environment, if you have to create a secret on your local developer desktop, you have to create a secret. You'll use Docker secret and give it a name. something like this, and point it to a specific credential file in a specific context, right? That's what we do. However, if we change the context, and in our example, if you remember, initially we changed the context to ECS, or we created the context as ECS. Let me scroll down. Why is it? I think screen is messing it up. So when we created the context as ECS here, right now, if I have to do like Docker secret ls, it will show all the secrets which I created. I can use, yeah.
So real quick, pull your. I think you might have to pull your terminal into the sharing bits. We can't see your terminal. There we go. Perfect.
Oh, I think there is a little bit of lag that is.
Okay, cool. There we go.
Got it.
Yeah,
right,
now we can see them. Awesome.
Right. So now you can do like Docker secret ls that will all the secrets, and these are bind context of ECS, and this is the pull credentials that I use for Docker Hub. This is database password, and I use the same Docker secret CLI in order to create it. But when I execute the same command against the ECS context, it creates into versus creating it locally. Right, so that's the major difference. But again, from a usability standpoint, developer, I did not need to learn anything else. Right, I just used it. It gave me an ARN and a resource identifier, and that was it.
Yeah, cool. That's it.
Right.
That's super powerful. Again, kind of your whole theme that you're walking through is being able to use a Docker CLI and not be an expert on everything in AWS.
Yep.
Right. So learning how to go into the console, create a secret, where do I store it, how do I manage it? You could do it all from the CLI. Yeah, it's
exactly
super cool.
Exactly. Right. Now, again, I mentioned that the Docker Compose CLI has a specific opinion, right? And that opinion is, and again, that is a well-architected opinion, and how the resources should be provisioned in, and what are the equivalent of source when it comes to cloud, right? So as an example, we went through secrets, right? Instead of use secrets in a file, I can store it in secrets manager. Similarly, so let's see if I do Docker volume with an S. You'll see, well, it's volume with an S. So I'll see.
Don't worry, I do the same thing all the time.
All right. So the opinion of Docker Compose CLI here is here. We created an elastic file system, which is Amazon EFS. It provides an awesome way to run stateful works. Multiple can mount to the same EFS drive. We are neither we executed Docker volume create command. It's all the opinion of our Compose CLI, which actually generated with the same syntax that we provided in the Compose file.
Awesome.
Right. Next question. Similarly, what is the equivalent of networks? Networks, as we know, is used for isolation, as in which service is, from a network standpoint, is allowed to access which other services, right? The equivalent of the security groups. So if I actually have to see the details of the security groups, I can go to EC2 and see the logical isolation from security group point also, right? In this case, my front end, I know that it should allow ingress rule, because I specified I want it to be public facing. That is why it is 0 to all. However, my backend network, I did not want that backend network to be accessed publicly, which is why I allowed only specific resources. The security group only will be allowed to access, right? So it is not public facing, it is neither exposed to public, all conforming to the best security practices without which without we doing anything, right? Now, in an enterprise environment, there will be usually separation of duties. When I say separation of duties, there are developer teams, there are network teams, and they have a specific area of responsibility. Now, in a typical enterprise, you'll see that the network operations is responsible for creating the VPCs, right? Which, as a good practice based on the separation of principles, and the developer teams don't need the access to, right? The VPCs are created by a network team. The groups could be created by a network team. The subnets could be created by a network team. That's the responsibility of a network team in generic. But how would we actually go about using that in our compose file, right? The answer to that is there are logical extension, Docker extension or compose. Not sure what is the exact term here, but these are the actions which you can specify and pin down your load balancer subnet, which could be public facing or private facing. You can pin down your services in a specific subnet. Again, if you don't want them to be public facing, you can subnet. And these are pretty much a standard which your network operations team will define and say that, hey, use this subnet if you're public facing, this subnet if you're not public facing, right? By default, we create a public facing load balancer. But if you want, you can override that. If you have a specific want to use for SSL for HTTPS purposes, you can override that if required, right? So this is pretty much about the Docker compose files and the overrides that we have given.
Yeah, sorry, Nish, that's huge, right? It's huge to be able to seamlessly use resources that are out there already, create your own, right? You can do them both. And I always talk about this on the show and other places. It's that layer of abstraction, right? Great technology gives you great abstractions, but then also allows you escape hatches, right? So
Exactly.
we got great defaults with the Docker ECS integration, but you can override those and plug right into the resources you already have on AWS, which is
exactly
super powerful.
Exactly.
Yeah.
I call it like smart defaults and override if required. That's what your principle and a saying goes, right?
Yeah, perfect.
Right. All right. So similarly, now let's say talking a little bit more about the security and the least security principle, right? So let's say if you have a specific service, and in this case, you have a backend service that needs access to a specific AWS created resources through APIs or API calls, you can restrict that access and the security roles also associated and associate that application with a specific role which is created for it. Now, in our application, our application is not using AWS SDK. The backend is not using AWS SDK. It is all the communication is all happening over TCP. Right, but if required, if you have a need that, hey, you want to communicate through a SQS as an example, and if you want to restrict that access, you can simply create the SQS resource and restrict something like this, right?
Yeah.
One more important thing. So here we saw that we created a load balancer. So if I go to dashboard and see the load balancers, we saw that, hey, the opinion was creating an application load balancer, which is a layer 7 load balancer. As an application developer, I am presented with like 3 different options or 4 different options now. Classic load balancer, application load balancer, network load balancer, gateway load balancers. Which one shall I select, right? Again, the smart default here, right? And again, that is our opinion conforming to the well-architected principles, right? If your application is you TCP protocol, you load balancer, which is the layer 7 load balancer. If your application needs to communicate over TCP, and here in this case, if I change the ports to like 5000, it will create a network load balancer, because it will the CLI will is smart enough to identify that, hey, this is a TCP port and I should be creating a network load balancer and application load balancer, which is really cool, right? Again, there are security rules which needs to be associated, and they work a little bit differently as compared to network load balancer and an application load balancer. Don't worry anything about it. It is all by the CLI. That is really awesome.
Yeah, really awesome. Yeah.
Right. So let's see first how this application looks like. Again, I went to console for the demo purposes, but you don't need to go to the AWS console to see sources which are created. So if I do Docker compose PS, that will show me, and it will take a few seconds, the load balancers which it created. It will show me the load balancer IP which it created, right? It shows me the backend service which it created in ECS. And if I open this in simple curl command, I should see the same application, right? I can do the same, like add to nudge. It showed me that. I can do the same, add repeater. Did the same. Absolutely no difference from an application standpoint, right? I can do the same here just for fun. Let me open this. Same thing, right? Pretty cool. Now instead of my local, I'm running the same mission into cloud without knowing much about what is exactly happening behind the scene as a developer, right? Now, the next step. What's next, right? The next challenge, not a challenge, it is for good. One of the reasons why customers migrate to cloud is for the scalability aspects, for benefits, and for the agility, right? And now we want to take the advantage of cloud and provision the resources when you need it, deprovision the resources when you don't need it, right? The answer to that is auto scaling. And we want to enable auto scaling in our application, and which is just another extension to say that, hey, scale up my services, which is a backend service, if CPU crosses above 75% for like 3 minutes or so. The 3 minutes is a default, but we can override that if required. But scale up if it is 75%, scale down if it is around 65, less than that, right? Add some capabilities. I want to enable PE tracing for runtime security analysis. Add that capability. If you want to drop a specific, you can do that. You can control what is the minimum replicas it should run. So I'm currently running one only, but you can say that, hey, run like 2 replicas if required. But anyways, auto scaling is enabled, so that will get kicked in if required.
Yeah.
Right? Yeah, so that is the next level that we start thinking, hey, instead of statically locking my resources to a finite number of resources on premise, I want to take the next step of enabling auto scaling, which is the next step of modernization, and one step closer to modernization. Usually, it is good to take small steps, and kind of, if you have a critical application in this way, you know exactly where the problem is, and there are like lesser learning curves which are required. So take small steps. I mean, first step we did was migrated the entire application, shifted it to cloud without modifying the experience. Next step is we started modernizing the application first and foremost by taking advantage of scalability and auto scaling in the cloud, right? What's next? Now, we are currently using, as we saw that we are using container image and mounting that image to EFS, which is great, absolutely works great, right? But what if we want to use a managed service like Amazon RDS or a relational database which will manage the whole database for you. You are just provided with an endpoint that you can connect to with the user ID and password credentials, and the backups are automated, and the restore process, if required, is automated. It is highly available. You can configure multi-site replication if required, multi-region replication if required. Tons of benefits of using Amazon RDS, again, as a managed service, right? So what if you want to use the same experience and extend that further to Amazon RDS, right? Again, Docker Compose overlay to do that, right? What I'm going to do is create an RDS database, and again, as creation of an RDS database takes time, so I have created it. Oops, let me log in here. So I created the RDS database, and come on. All right, let's load. All right, so RDS. And again, creation of this RDS database also can be done using Compose file. What you have to do is on the top, we have mentioned like X CloudFormation resource. You can leverage the same extension and create any resource, any Amazon supported by CloudFormation. In this case, we are using it only to override a few properties, but you can create new resources also using this extension altogether. Awesome. But at the same time, databases can be created from here also, and you may have like different teams, your DBAs, which are responsible for creating the database. So they can go in console or manage it through infrastructure as a code. Use the same version of, currently I'm using the free tier as an example, but use the same version, which is 2.0.10 here. Give it an identifier, use the credentials or specify the credentials that you want to use, and few details here, which is going to create the database for you. In the provided with a few endpoints that you can use it for host, use as host, which is the endpoint. Use the ports, and you know the user and passwords, which we have already created as an example using secrets manager using Docker Compose Docker scripts in the ECS context, right? So
Awesome.
what I'm going to do next is run the same application. Run the same context, run the same set of Docker Compose commands, but overlay with an additional thing, right? I'm doing is with my backend, adding few environment variables of the host file where my secret is, and this is mentioned as when in runtime, when the secrets are mounted, let it be through a file or through secrets manager, it is mounted to a file locally that we specify here, right? And that is used in the application to actually connect to the database, right? So let's actually go there and run this. Clear this off. Same command. Yeah, and add one more overlay file. Docker compose RDS, and do Docker compose up, right? Okay, so my credentials in this case have expired. Let me refresh it again. And by the time anyone tries to see this, it will be expired, so I don't need to worry about anything. I'm using specific ECR registry also. So let me just authenticate against that. All oops here and here and here. And it should be soon.
While you're doing it, I'm going to promote DockerCon.
Sure.
So DockerCon is coming up soon. Go to docker.com/DockerCon. Get signed up for when we open up registrations. Our CFP, call for papers, is going to be published soon on Monday. So if you're looking to give a talk, keep an eye out for that. We'll definitely be out in our, we'll push it out in social media, blog, and it'll probably be in our newsletter a little bit after that. But yeah, super excited for DockerCon coming up.
Yep, looking forward. That is in May.
In May. Yep.
Nice. All right, so I got that working. It is executing the CloudFormation templates, or generating the templates and executing it. So you'll see that the in few minutes is still start changing to update in progress, right? Again, you can keep on sending the traffic. The updates are pretty much a rolling update, which means that the new container image will come up as we overrode it with the specific parameter that will come up. And once the health check passes, only then the old container will gracefully start draining the traffic so that there is no impact. Right now, in an ideal scenario, what you would want to do is create a stack in cloud, do database migration, also backup and restore from the NFS drive to RDS, and then do the cutover, right? Or there are many database migration techniques that you can make use of. But from an application standpoint, this is pretty much it. I mean, other than overriding with a specific Docker file, it will take its own 5 to 10 minutes more to kind of gracefully drain it off. And one more thing. When this all is happening, if you want to see the logs of the services real time, Docker Compose logs will stream all the logs from all the containers from all the services real time. It's pretty much similar as what you'll see in console, but these logs are streaming real time. You can actually see when the traffic is coming, what exactly is the traffic coming. You'll see that when a new container image comes up, start showing that also. When the health check passes, it will start showing basically every request and response is logged for your application.
Yeah, that is super cool. Super cool. Just again, like you were saying earlier, just like you would be running locally.
Yep. I mean, basically, what you saw that I personally did not make an AWS CLI call or interacted with CloudFormation, or actually went to or executed any AWS CLI calls even to view any resources. What I did was created a context specifically for ECS, overrode it, my application specific parameters, and that's it. Use Docker Compose in the file one after another, based on the image, based on the phase of action, and pretty seamless experience from a customer standpoint.
Yeah, it's awesome. It's awesome. So maybe we can jump back real quick. We got a couple of minutes left here.
Yep.
I don't think I've ever explained or walked through Compose overlays. Can you kind of maybe walk through how that works?
Absolutely.
Yeah.
So going back here, right? So we have Docker Cloud. You can use the term overlay in like different teams that you want to, different purposes that you want to make use of, right? But what exactly is I create one Docker Compose file and then use another Docker Compose file, and by simply passing -f parameters, right? What it is doing is kind of merging all the aspects and all the services into one file behind the scenes, right? And overriding where it is required and where it is necessary. So as an example, my in the very first proxy in my local environment, I'm actually building the proxy layer using build context. But when I want to a specific environment, I have already image in form of I mean, it is already present in a, URL in a specific registry, and I need to just refer that. So with the image identifier here, so write the the build context here.
Mm-hmm.
Everything else remains the same, but only that specific property is overwritten. But again, the beauty is we did not uh, as a developer did not write that logic altogether, that hey, when you promote to environment or a test environment, override this specific variable with this specific property, right? You find environment specific files, you can define environment specific compose that hey, this is my base file which I'm going to use as a developer, but in developer environment, these are some of the specifics that I should be overriding because I'm using a different AWS account, or based on the reason which I described, that hey, I'm using a already which is produced by my CI/CD system, or maybe because I want to logically separate out my services, which I have many reasons to do that, many purposes to do that. But in this case, what we use the overlays is essentially two folds. How and what are the resources which going to look different as my local environment versus where I'm running. And secondly, there are a few smart defaults that the CLI provisions, and I want to override with the specific parameter if required. So these are the two reasons, and again, third is for demo purposes, right? It's easier rather than going through the whole big compass. I can just simply show this.
Yeah, no, it's perfect. Thank you for doing that. Yeah, it was super powerful. You know, the overrides, and you just demonstrated it today on how using that. I love doing that, using that base Docker Compose file, right, and then laying over top your environment so where you need to go. Yeah, super. And the CLI, the integration of AWS with the Compose extensions, make it super powerful to connect right into AWS, all of its resources, and then ECS, and it allows you to walk, to crawl, walk, run, so to speak, right? So you can get something very basic, take all the defaults, and then build on top of that as you build out your application. You need to scale it and go into more public production facing environments. Yeah,
exactly.
Awesome.
Right? And again, we would love to hear from our customers, right? I think there is a GitHub issue link that we can probably post, and you can reach me out also. It was also fine. We would love to hear from customers and from you all, firstly in form of roadmaps, or secondly, if you are using this and you're seeing a different experience, anything that you would like us to improve, any feedback that you want to give us, we are always there with all our ears open to listen to that feedback and make product iterations based on that feedback. So your feedback is super important to us, as in what is working, what is not working. We like to hear more about that.
Absolutely. You're making my job nice and easy, Anuj. I appreciate it. But yeah, go to the roadmap. That is our public roadmap. Our PMs are in there all the time. Our engineers are in there all the time. That is what we are working on. So search first for your issue. And if you don't find it, then submit it. But join in the conversation. On the features, our project managers are in there. Our product managers are in there. Our engineers are in there. So it's a great way to interact with Docker engineering. And And then we do really use that to prioritize. So go check out the roadmap. Also, too, I'd like to say, join our community. There you'll see all of our meetup events and different community events. And then also you can join our Slack, our community Slack. We have a ton of people in there, communities in there. It's people are talking and answering and asking questions all the time. A lot of our engineers are in there. Our captains are in there. So it's a great place to kind of connect in with the Docker community. And then, of course, follow Anuj, check him out on GitHub. That's kind of his landing place, and you can find him from there, different places on the internets. And then feel free to follow me on Twitter, follow me, and reach out to me on the community Slack. Love to have your questions, comments. Don't hesitate to reach out. I do always give a caveat. It is very hard to help troubleshoot your specific environment in Slack or on Twitter. So if I can't give, huge in detail troubleshooting or customer support, please forgive me. I just talk to a lot of people, but we do have other alternatives routes. So if I can't get you help, I can get you pointed in the right direction. But awesome. Well, Anuj, thank you. Thank you so much. This has been
thank you, Peter. It was great talking with you and so many customers, right? Glad, looking forward to hear more from customers about how this integration is and what are the areas that we want.
Yes, likewise. And I have an open invitation for you to come on the show anytime you want. We can talk about the integration or all things cool. But yeah, thanks again so much. Really appreciate it. Okay, everybody. Well, thanks for joining us again. We'll be back again next week, next Thursday. If I don't see you in the community on Slack or on the roadmap, have a great weekend, and we'll talk to you next week. See you, everybody.
Thank you,
Thanks.
Everyone.